Okay, question 2b part 3. In this question you need to sketch the graphs of the two rocks from the time they left the hands of the man to the time just before they reached his friend. So in the case of the first rock, it has been released, therefore its initial velocity should be 0. After that, the rock will fall under the effect of gravity. The acceleration will be 9.81 meter per second square. And since we are taking downward as positive, the A will be a positive 9.81. So to draw the graph for rock 1, I should start with initial velocity 0. Acceleration is constant and it's positive, therefore the gradient should also be positive and constant until the time when it touches the friend. So this is for rock 1. Okay, in the case of rock 2 is being thrown down. After it's been thrown, it will also fall under the effect of gravity. The acceleration is also 9.81 due to the gravity pull, positive. So for rock 2's graph, the initial velocity is u, so it shouldn't start from 0, and rock 2 was being thrown 0.5 seconds after rock 1 was being released. Therefore, we should start rock 2 graph 0.5 seconds later, and it should have a certain u value at the start. After which, it should be a straight line graph having the same gradient as rock 1 until it reaches the friend, rock 2. The reason for the same gradient as rock 1 is due to the same acceleration. Next, to draw the displacement time graph, both rocks start from the man's hand, therefore the displacement should be 0 at the beginning. For rock 1, it has 0 initial speed. The gradient of the displacement time should be 0 at first. However, the velocity started to increase at a constant rate, therefore the gradient of this graph should increase. Therefore it should be a upward sloping curve. So this is for rock 1. For rock 2, it was being thrown 0.5 seconds later, so we should also start the graph 0.5 seconds later. For rock 2, the initial speed is not 0, therefore it should start with a certain gradient, non-zero gradient, and it continue to increase. So the gradient will increase to get steeper and steeper until it meets at the same point. So this is rock 2. Why must rock 1 graph meet at the same point with rock 2? Just because both rock 1 and rock 2 would have traveled the same displacement. Okay, next question. Question 3b. In this question, the batter hit the baseball at a height of 1.5 meters, therefore this should be 1.5 meters. The baseball was hit at an angle of 60 degrees at a speed of 35 meters per second. The catcher will be catching it at a height of 3.5 meters. So what is the distance that he should position himself? So we're looking for the horizontal distance over here, and we'll label it as Sx. So to solve this question, I'm going to use kinematics equation in the vertical motion. I'll be using Sy equals to uyt plus half ayt square. I'm going to take upwards as positive. So the vertical displacement from the initial point, which is here when the ball was hit, until the final point when the ball reaches the catcher's hand. will be the difference between the 3.5 meters and the 1.5 meters. So 3.5 meters minus 1.5 meters, that will give me the vertical displacement from initial point to final point. Initial vertical speed should be 35 sine 60 multiplied by the time, which is unknown, plus half AY. AY is pointing down due to gravity, so I should have negative sign, minus 9.81 t squared. So if I solve this equation, I should be able to get two answers, 0.0667 second or 6.10 second. So which one should I reject? The first answer, 0.0667 second, will be the time when the ball is still moving up. Therefore, I will reject this. 6.10 second is when the ball is on its way down. So I accept this. In order to find Sx, I will use this formula, uxt plus half axt squared. Since there's no horizontal acceleration, I can cancel this to be 0. Sx will be equals to the horizontal speed, which is 35 cosine 60 degree multiplied by the time. In this case, found to be 6.10 second, and therefore the answer is 107 meters. For part C, you need to sketch the path of the baseball if air resistance is not negligible. So in this case, if air resistance is significant, the ball will experience air resistance on its way up, and hence it will not be able to reach the same height as before. So the maximum height should be reduced. And horizontally, the baseball will also experience air resistance. Horizontally, the baseball will not be able to move as far as it wants it to be. Hence, the path will look like this. Okay, and take note, for path where air resistance is not negligible, it should not be symmetrical, because as the baseball continues to fly horizontally, it will experience air resistance, and this will cause its horizontal speed to reduce continuously. Therefore, the path should look like this: asymmetrical with a lower height